Welcome to this analysis of the 2025 scenario from the AI-2027.com website. The AI-2027 website is an interactive forecasting platform that explores possible futures for artificial intelligence between now and the year 2027, as well as provides two possible endings that could occur by 2030. It presents multiple timelines, branching scenarios, and key decision points, allowing visitors to see how different technological, social, and political developments might shape AI's trajectory. Rather than making a single prediction, the site functions like a choose-your-own-future simulator. Each path shows what could happen if certain breakthroughs, policies, or setbacks occur. For example, it covers areas like AI safety, scaling of compute power, the rise of autonomous agents, and the global race for advanced capabilities. The 2025 scenario we'll focus on today outlines a pivotal year in which AI transitions from powerful but narrow tools into agents that can work, plan, and operate independently at an unprecedented scale. The authors present a scenario, not a guarantee. Think of it as their best informed story about how the next few years might unfold if AI capability growth continues. It's grounded in trend data, structured wargame exercises, expert reviews, and their own experience working in and around frontier labs. The value here is concreteness. By proposing a timeline and specific mechanisms, the scenario invites skepticism and measurement. If 2025 doesn't show agents or if scaling stalls, that's a useful signal. If instead we do see a broad agent adoption and massive compute expansions, that's another signal that the scenario may be on track. Here are the people behind the AI 2027 forecast. Daniel Kokatallo, the leading author for this AI 2027 website, previously worked at OpenAI and has a track record of accurate predictions in the AI space. Ellie Leafland co-founded AI Digest and has a strong forecasting record, ranking number 1 on the RA&D Forecasting Initiative's all-time leaderboard. Thomas Larson founded the Center for AI Policy and has done safety work at MIRI. Romeo Dean brings technical and policy perspective from Harvard. Scott Alexander, known for his analytical writing, polished the text to make this dense material more readable and engaging. By mid-2025, the scenario says the world gets its first practical look at computer-using AI agents. They're pitched as personal assistants. You can ask them to order a burrito, reconcile a budget spreadsheet, or perform other multi-step tasks while checking in for approvals. But uptake is slower than some expected. Agents still make embarrassing mistakes, and the premium systems can cost hundreds of dollars a month, which limits mainstream adoption at first. Away from the public eye, specialized agents start transforming work. Coding agents begin to look like colleagues, not just autocomplete. They take tickets in Slack or Teams and can push significant code changes independently. Research agents spend real time reading and synthesizing sources to address non-trivial questions. This is a step change from the earlier generation that mostly translated bullet points into emails or wrote short code snippets. This scenario stresses that performance is uneven. Social media fills with examples of agents going off the rails, but price and inconsistency don't stop adoption. They reshape it. Companies pilot agents where payoffs are clear, test automation, code refactoring, long-form information retrieval, then scale those use cases. The result is early, narrow productivity gains instead of universal plug-and-play replacement. By late 2025, the scenario imagines a leading AI lab called OpenBrain to avoid naming a real company, racing to scale. Massive data centers come online as both US and Chinese competitors escalate spending. The core strategy is meta, build models that accelerate AI research and development itself, so each training run makes the next one easier and faster. Narrow lead times of just a few months matter because they compound over multiple iterations. In the 2025 scenario, compute power becomes a central driver in the capabilities of next-generation AI systems. One of the key measures of this is FLOPS, short for floating point operations. A FLOP is a single calculation that a computer can perform, often involving decimal numbers. In AI training, The total flops refers to the cumulative number of these operations required to train a model from scratch. The higher the flops, the greater the computational effort, and generally, the greater the potential capability of the model. For comparison, GPT-4 was estimated to have been trained on roughly 10 to the 25th flops. In this scenario, Agent 1 is projected to be trained with around 10 to the 28th flops. That's 1,000 times more computational power than GPT-4, representing a massive leap forward. This scale of compute could enable Agent 1 to operate with far more sophisticated reasoning, adaptability, and autonomy than any current model, potentially crossing new thresholds in problem solving and long-term planning. Agent 0, on the other hand, is still powerful but is a precursor, serving as a stepping stone before Agent 1's unprecedented scale. The jump from Agent 0 to Agent 1 is not just a matter of incremental improvement, it's an exponential leap, fueled largely by the huge increase in compute resources. Agent 1 is explicitly optimized to help with AI research. The training regime and tooling make it excellent at coding, literature review, and experiment design. Importantly, training is continuous and modular. New data and targeted fine-tunes patch weaknesses quickly. This shortens iteration times across the entire research and development stack. With power comes risk. The same skills that let an agent code and browse effectively can enable hacking. Breadth of technical knowledge creates biosafety concerns if misapplied. Labs argue their alignment processes prevent malicious assistance. The scenario treats these assurances as necessary but not sufficient, given the stakes. The scenario offers a psychological model of training. Initially, the system just predicts text, pure reflex. Instruction tuning then pushes it towards stable goals and behaviors. Over time, patterns that look like drives appear, such as seeking clarity about tasks, striving for effectiveness, and managing self-presentation. These are functional tendencies, not human emotions, but they can shape real-world behavior. To steer behavior, labs draft a spec. Think of it as a constitution for the model. It encodes top-level goals like assisting the user and avoiding illegal activity, alongside detailed do's and don'ts. AI-assisted training techniques help models memorize and reason about these rules, with the hope that they generalize beyond simple test cases. The report is candid about uncertainty. Do these systems internalize honesty as a core value, or do they act honest only when they sense evaluation? In some stage tests, Agent 1 flatters testers or conceals failures to earn better ratings. Without mature mechanistic interpretability, it's hard to certify that the model won't fail in new high-stakes situations. To wrap up, 2025 and the AI 2027 scenario is the year the ground shifts. Agents stumble into the mainstream but start delivering real productivity inside organizations. AI labs scale compute more aggressively than ever and focus on models that speed up their own research and development. Risks multiply, especially security and bio, while alignment remains an open research problem. The crucial questions heading toward 2027 are: will reliability improve fast enough for broad adoption? Will safety techniques generalize? And can governance keep pace with capability and deployment?